Alright, so I want to continue talking about U-substitution and this method of integrating here. And so what we have in front of us here is an example. I want to find the integral of this messy looking thing here. And one of the things you might be wondering is, or might already be thinking, is that you might want to let U equal x squared plus 3, but you might be a little hesitant in doing that because you see that you have a 3x, not a 2x. When you take the derivative of the inside, you'll get a 2x, not a 3x. So what can we do here? Well, before I even start doing anything or start making any type of substitutions here, this 3 right here is a constant. So what I can actually do is factor it outside or bring it out in front of the integral. So if I do that, I'll have 3 on the outside, and I'll have the integral of x, and now I'm going to have the square root of x squared plus 3 dx. And now I can go ahead and start working with this, and I really don't have to focus too much on this 3 anymore. I can now just concentrate or at least put most of my attention here rather than letting this 3 get in the way, if it gets in the way at all. But anyway, let's try making a substitution here. Let's say that we let u equal this x squared plus 3. Let's see what's going to happen. So we're going to say that u equals x squared, oops, I forgot my square, x squared plus 3. Now I want to take the derivative of this, so again, that means that du is equal to, the derivative of this guy right here is just 2x, and then the derivative of 3 is 0, so we have 2x, and then we have our differential here, our dx. And looking at what I have here, I don't have a 2x dx. What I have is an x. I have an x dx here. So what I'd like to do is make this right here look like what I have here highlighted in blue. Well, how do I get rid of this 2? Well, I can easily just divide by 2. So if I divide by 2, I'll have 1/2 du is equal to x dx, and that's just dividing everything by 2. So now what I notice here is that I have an x dx, and that's perfect because I have an x and I have a dx right here. So I can now substitute x dx for 1/2 du. So now my integral, so now I can rework my integral. I can say, well, my integral is going to equal, I have this 3 on the outside. Now the square root of x squared plus 3, remember I can substitute that. Remember we said that u was equal to x squared plus 3. So what I can actually do is say, well, this is going to be the square root of u, and instead of having x dx, instead of having an x dx, I can replace x dx with this 1/2 du. This 1/2 du. And now the 1/2 is just a constant. So the 1/2 is just a constant. It means nothing. It has nothing to do with our variable of concern, which is u. So I can actually pull that out. So I'll have 3 over 2, right? Because 3 times 1 is 3, and then the 2 will stay in the denominator. And then I'll have the integral. I have the integral of the square root of u, but remember I can rewrite this as u to the 1/2, and then we have du here. So we've already done our substitutions. This integral is a lot easier to integrate and a lot nicer to look at, by the way, than looking at this messy thing right here. So let's go ahead and finish off this problem here. We're now going to have, this is going to equal, let's see, 3 over 2. U to the 1/2, again, remember we're going to add 1, so that'll become, let me do this in green, that'll become u to the, let's see, 1/2 plus 1, that should be 3 over 2. And again, I have to divide by 3 over 2, but remember that's the same thing as multiplying by the reciprocal, so I can easily just multiply by 2 over 3 instead. And then I have to tag on this plus c since we are doing an indefinite integral. Now all that's left for me to do is just clean some things up. For example, I notice that these fractions here will reduce each other out or cancel each other out. And what I'm left with is u to the 3 over 2. But I got to keep in mind, well, what was u? Well, we made this substitution at the very beginning. We said u is equal to x squared plus 3. So this is really just going to equal x squared plus 3 to the 3 halves, and then we have this plus c. And if you're not sure, if you're not very sure about your answer, if you're correct, you can always take the derivative of this. So you can always take the derivative of this, and if you take the derivative of this, verify that you get this thing right here. And if you do, then you know that this here is correct.